All right, let's continue our notes on complex circuits. So we have an example circuit here. You'll notice as you follow through the battery, battery, then we have a split here. You have a resistor A, resistor B, then they come back together. Those little green boxes, not part of the circuit. They come back together here. Resistor C, and then there's another split, resistor D, then resistor E, and they come back together and back to the battery. First thing we're going to focus on is finding the equivalent resistance of this circuit. What we'll do first here is we're actually going to take this and we're going to write in the resistances of the individual resistors. So resistor A is 2 ohms. Again, I'm not going to put in my symbol because it's a pain. Resistor B, 2 ohms. Darn thing. Resistor B is 2 ohms. Resistor C is 7 ohms. Resistor D would appear to be 4 ohms, as is resistor, go down, resistor E is also 4 ohms. Now we need to start recognizing which part of the circuit is what type. Anytime you're looking at one of these circuits and you see a split in the line, as in this location right here, that location right there where I'm holding the mouse, that means a split in the road means we have a parallel portion of the circuit. So it would appear that we have two paths. One path follows through resistor A, the other path follows through resistor B. Then they come back together. So AB, resistor AB, is one parallel portion of the circuit. And we follow through. C has a single path, so it would appear to be all alone. And then here at D, we have another split, and it comes back together there. So it would seem that we have a parallel portion with AB, a single resistor, and a parallel portion with DE. Let's start finding the equivalent resistances of sections AB and sections DE. Section AB, I'm going to move the box instead. Resistance AB, 1 over resistance AB, is going to equal 1 over 2 ohms plus 1 over 2 ohms. So we'll use a little bit of math here. A half plus a half equals 1 over 1 ohm. We still got to take the reciprocal. And while this math is real easy, I think you should still write it this way so you recognize what's happening. 1 over 1, and you take the reciprocal, and you get a resistance of 1 ohm. Okay? 1 ohm. So resistance AB is 1 ohm. Then let's do resistance DE. So grab my box again. Hey, come on. Resistance DE, I'm sorry, I miswrote this. 1 over resistance DE is equal to 1 over 4 for the 4 ohms here, plus 1 over 4 for the 4 ohms there. So a fourth and a fourth is a half. So that's 1 over 2 ohms. And then we need to take the reciprocal of 1 over 2, and that's nice and easy. That's 2 ohms. So resistance DE is 2 ohms. Well, then it's kind of like, let me redraw here real quick. If we redraw this, we've got battery, we've got AB as one thing, we've got C as one thing, and then we've got DE as one thing, and it comes back together. And when you look at that, now it doesn't look like parallels, now it looks like a series. So what we have to do here is we have to add AB plus C plus DE, because in a series, resistance is simply added up. So we grab a hold of this box here. Resistance A, B, C, D, E, so that's all of them, equals 1 ohm for AB, plus 7 ohms for C, plus 2 ohms for DE. So my equivalent resistance for the whole circuit is going to be a whopping big 10 ohms. That's my equivalent resistance. And that's going to be our main focus for the homework you're going to do today, is just figuring out the equivalent resistance. Our next lesson will be about finding the current and the voltage and all that, like I did in the other sample. But this is going to be your main focus here today, is just finding equivalent resistance of these circuits. Now, I'm going to tell you, the biggest trick you have with that assignment is calculating, or not calculating, you guys can handle the calculations. It's a matter of figuring out what the drawings are. So let's look at how I have the drawings indeed drawn here. We'll come back to this. Drawing number 1, you've got a resistor, and then you got this kind of shape and these two resistors here. And what you really have to figure out is what is parallel and what's a series. Because some people would probably tell you, oh, look, that's in a straight line, that's a series. Except, of course, that there's a branch here. There's a branch in the way. So these two are parallel to one another, and they're in series with that one. Then when you look at this one, you got the same scenario on the side over there, but you got a parallel part, then you got a single one, and then you got another parallel part right here. So when you're working on these problems in the homework, be very cautious of the shapes that you're seeing and how they work. Let's go back to that page here, and here's the homework. It's on 647. And in 647, you're going to exercise this a few times. And they don't give you easy numbers to work with on these. Like for number 1, it's 25, 3, and 40. Not exactly easy to work with, so it's going to just really make you practice. All right. Good luck with that homework.